Well, hello. You are watching 1.4 Solving Absolute Value Equations video. So we are going to talk about absolute value. With absolute value, the idea is to think of it as a distance. How far away are we from 0? So if we think of the number 6, we could be at positive 6, or we could be at negative 6. They're both 6 units away from 0. So the absolute value of 6 would be 6. And the absolute value of negative 6 is 6. Because again, it's the distance you are away from 0. So if we go ahead and look at what absolute value symbols are, they're just kind of a line on either side, kind of like a bar there. If we're talking about it in word format, we would look at it with, if it's a positive number greater than 0 or equal to 0, then it's going to be that number. So let's say A, well then it would just be A because it's already positive. But what if that number was negative? Well then we would just make it a positive, kind of like we did with negative 6. That answer was 6 for the absolute value, that distance away from 0. So let's go ahead and model this one. We have a distance of 4 away from 0. So we could be, here's a distance of 4. We could be at positive 4. Or going this direction, here is a distance of 4. So we could have the absolute value of negative 4. That is also equal to 4. So thinking of it as we have both positive and negative. So let's go ahead and try solving some equations with absolute value in it. We want to make sure absolute value bars are treated like other grouping symbols, kind of like parentheses. You do them first. If they're going to give you a value for x, you're going to go ahead and plug that in. So let's go ahead and take a look. 2 plus the absolute value of 6 minus 2 times 4. And close that absolute value. So work your way inside out. Multiply first, keep those order of operations. But remember that these are not parentheses, they are absolute value symbols. So when we do 6 minus 8 and we get negative 2, we actually have to do the absolute value. How far away is negative 2 from 0? It's 2 units. Again, distance is always positive. So 2 plus 2, our answer should be 4. Absolute value, the answer that comes out of an absolute value is always positive. Go ahead and try B on your own and then check when you're ready. And hopefully you got 2 for your answer. If not, pause the video, look through those steps, and find where you made your error. All right, so for the next page, solving an absolute value equation, geometrically, absolute value of x is the distance of x from 0. So both 3 and negative 3 are 3 units from 0. So the absolute value of 3 is equal to the absolute value of negative 3, which is 3, because that's our distance away, and it's never negative. So the actual solution of that absolute value isn't. But when we think of it like what could A be to give us the absolute value simplified, a distance of 5, it could be 5 or negative 5. Because if we replaced any of those with those values, it would give us that absolute value. So these are going to have 2 solutions when we solve for our variable to find out what that x could be. It could be b, or it could be negative b. So we're going to do some solving today. So we want to think about isolating that absolute value sign first, meaning getting just that on one side. Then setting whatever is inside the absolute value equal to both a positive and a negative value. Just like we saw up here, it could represent both those. So solving both equations then, after we've set it up, you should have 2 answers because there's 2 equations. So let's take a look at what that looks like. Again, a very important first step of actually getting that absolute value alone. So if we look at our left side, if you want to go ahead and draw like a dotted arrow or a line down that equal sign, just to make sure you keep things on the sides that they're supposed to be on, And if you're going to do something on one side that's going to undo something, you need to make sure to do it on the other side. So if that helps you, go ahead and do that. So first, we're going to look for this being isolated. Yep, it is. So we can go ahead and move to step 2. Setting up two equations, one equal to a positive on the other side and one equal to a negative, not where the absolute value is. So that would be the 8. So we're going to have x plus 3 equaling positive 8 and x plus 3 equaling negative 8. And really I wanted this to kind of be on the other side of the equal sign, so we can kind of move it over here. But we are going to have two equations, so it is good to kind of separate things so that we keep things all nice and neat. Okay. So our first equation here, you can keep the absolute value bars, but really when it comes to solving, you're going to be moving out from them, so you don't really need them once you've set up both equations there. So solving, minus 3 on both sides, and x equals 5 for your first answer. We are going to check these though, checking our solution. And over here, subtract 3, and x equals negative 11. So let's go ahead and check and actually make sure that these are solutions. Plugging it back in, 5 plus 3, absolute value of 8, yep, is 8. Negative 11 plus 3, that's negative 8. Yep, absolute value of negative 8 is 8. So they both work. So it's good to check and make sure that your answers are correct. All right, go ahead and look at the next one. We've got something with the absolute value. We've got to get that away first. Then we'll set it up like we did on A. So we've got 15 equals the absolute value of x plus 12. Now it's alone. Let's set up both those equations. So the first one is going to be 15 equals x plus 12, and negative 15 equals x plus 12. Again, we make the side that's not the absolute value negative. So we're going to solve both of these. Just kind of split things off here so we can see both our equations. So to solve, we want to subtract 12, and x equals 3. Again, go ahead and plug it back in up above to the original to check and see if it truly is a solution. X equals negative 27. So over here on this one, C, we've got a couple things we've got to do first before we can set up our two equations. So first, get rid of what's being added or subtracted, because we, again, just want this alone, just the absolute value. So get rid of your 4, and then get rid of your 2. And how do we undo multiplication? Oh yeah, division. So now that we have 3x, the absolute value of that by itself, we can set up our two equations. So one equation would be a 3x equals positive 6, and one would be a 3x equals negative 6. Make sure to wait to set up these two equations once your absolute value is all alone. Very, very important. Once that absolute value is all alone, then set up your two equations. And now we can go ahead and solve. So dividing by 3, x equals 2. Dividing by 3, x equals negative 2. And plug them back in to check. Go ahead and try D on your own. It's just like C, so we want to get rid of this first, then get rid of the 8, and then set up your two equations and solve. And then press play and check when you're ready. All right, so check your answer. You can always pause the video or rewind to go back and watch C, or pause and check D step by step. But make sure that you've got that absolute value by itself before you set up positive equal to positive 4 and equal to negative 4, and then solve. It's not always going to be a pretty whole number, so keep that in mind too. All right, and flip into the next page. Let's talk about no solution. What's going to happen if we have something that's unsolvable or impossible to solve? Well, the absolute value of anything can never, ever equal a negative. Negative anything, negative number. Remember that? So absolute value is distance, and distance is never negative. Even if you think you're going backwards, you're still walking a certain amount of distance there. It's just a different direction. So let's take a look at this one. If we were to subtract 5, it's the absolute value of 6 minus 4x equaling negative 5. Uh-oh. We cannot have absolute value equaling a negative. So this would be no solution. No solution would work in this equation because it would give us a negative with an absolute value. Over here, divide to get that absolute value alone, because we know that's always our first step. And we get negative 3. Uh-oh. Again, absolute value cannot equal a negative. Distance is never negative, so no solution. Not possible. All right, little vocab here. Talk about constraint and extraneous. So a constraint is just a condition that a solution must satisfy. So we know that absolute value of anything, of x, has to be positive. And we know the square root of a number is going to be positive, because remember, a negative times a negative, that's a positive. So we know that the square root of a number has to be positive as well. So those are just constraints. What if we have an extraneous solution, meaning a false solution found using correct math? Well, we actually do it correctly, but it's not really the correct solution. That happens, and that's called an extraneous solution. So for example, if we were to square this to solve for x, we'd square this side, and x would equal, well, negative 5 times negative 5, that's 25. But is the square root of 25 equal to negative 5? No. But we use the correct math, so it should work. But no, it didn't. So that would be called an extraneous solution. So let's take a look at some examples here with absolute value. We're going to solve, finding our two solutions, and then we're going to check and see if, because possibly one or both could be an extraneous, meaning are not a true solution, but we did it correctly solving-wise. So notice that the absolute value is alone, so we can go ahead and set this up with a positive 2r plus 3, which would look like this, and a negative 2r plus 3. Now when you put the negative, it really means the whole right side. So that means we need parentheses so that we get the whole right side negative. So when we stick in our little separation there so we can actually solve, what do we do when there's variables on both sides? I like to get rid of the smaller one. But you could always move the constants to be with each other. It really doesn't matter. And then let's add 3. So we get 11. And let's go back and check here in just a second. Let's solve our next one and we'll check both of them. So over here, distribute. Negative 2r plus 3. Careful with those negatives. And then let's go ahead and add 2r. 8 equals, 8 plus 3r equals 3 minus 8 minus 8. 3r equals negative 5, divide by 3. Got ourselves a fraction there. All right, so if we were to plug this back in and check, we would wind up with 8 plus 11, the absolute value of that, equals 2 times 11 minus 3, which would wind up giving us 19 over here and 19 over here. So yeah, this is a solution. Now if we plug this one in, it would give you 8 plus negative 5/3. And this one's actually going to be a no. So I'm just going to go ahead and tell you that now. But if we were to go through and actually simplify each side, there we go. It would wind up with 6 1/3 equaling negative 6 1/3. And that is not equal. So this one is an extraneous solution. It is not a true solution. Go ahead and try B on your own. Remember that you first need to get the absolute value alone. So you're going to add g to this side, and then you're going to divide by 2, and then you're going to set up your two equations. So go ahead and try that, and pause, and then push play when you're ready to check. Go ahead and check just this part if you haven't started already, making sure to add g and then divide by 2 to get the absolute value alone, and then set up your two equations. So now go ahead and solve, and then check your answers. All right, so you can push pause and check your answers and see how you did.